This video we're going to be going over Theorem 2.055, and it's going to be equivalent to our congruence, except it's going to be for Saccheri Quadrilaterals inside hyperbolic geometry. So we'll say congruence, theorem for Saccheri Quadrilaterals. So that's the name of our theorem. It says, given, and by the way, this is a longer one, but it can still be done in one video. Given a Saccheri quadrilateral or we'll say given two Saccheri quadrilaterals. That'll be A, B, C, D, and A prime, B prime, C prime, and D prime, with congruent lower bases AD and A prime, D prime, and congruent heights AB congruent to A prime, B prime, and the other height would be, let's see, actually, let's say AB congruent to CD, congruent to A prime, B prime, congruent to C prime, D prime. That way we can have it all in one expression. Then the upper bases BC. So the upper bases are congruent. So BC is congruent to B prime, C prime. We'll say angle B is congruent to angle B prime, and the other upper angle would be C. So angle C is congruent to angle C prime. I should be spelling out those angles in a little bit more detail, but we're far enough along to where that's not too big of a deal. So that was just stating the proof. Like I said, this is a longer one. We'll say, let's draw these out. I think if we do it down here, we can fit this all in one page. We'll make that one the prime one, so A, B, C, D, and that's all prime. And I'll do this one in green, the regular A, B, C, D one. So we'll pretend my artwork's perfect and that these are all even. Let's see. We'll show that these are all equal and these are equal. Let's see, what else did we say? We also said that this angle is congruent to that angle, and this angle is congruent to that angle. So we'll say given the two Saccheri quadrilaterals as stated, because I don't feel like writing all that out again. By side angle side, triangle ADC is congruent to the prime version of that, so A prime, D prime, C prime. So let's see. ADC, which means these two are congruent, so I can make, let's just draw 3 marks there to show congruence. Then by corresponding parts, of congruent triangles, AC is congruent to the prime version of AC, which that's what I just now did with the teal lines there. Also, by corresponding parts, of congruent triangles, angle CAD is congruent to its prime. So angle C prime, A prime, D prime. Let's do that in purple. We're getting kind of a lot of teal down there. So CAD is congruent to that. Then by angle subtraction, angle BAC is congruent to angle B prime, A prime, C prime. So BAC will, even though it is a lighter purple, we'll just put that hash mark there anyways, make it clear. Then by corresponding parts, of congruent triangles, angle B is congruent to angle B prime. See, we already had that, so we'll leave that alone. And BC is congruent to its prime version. Let's do that in, we can do regular blue there. And this is, let's see, this is only the first half of the proof. We'll just take a shortcut and say by drawing, or not drawing, we'll say by constructing the other diagonal, we can do a similar proof, which is just the same proof as we just did there, except backwards, and obtain angle BCD is congruent to angle B prime C prime D prime. And our proof is complete. So I didn't do the whole proof there because we would have had to double all that work, but it's the same thing. It's pretty much done. And I think you all see how to do the rest of it.